Section 8.4, Example 2 on page 534, we have a composition of reflections across two intersecting lines as a rotation. You can write this composition as the reflection over line M of the reflection over line L of triangle ABC is equal to triangle A double prime, B double prime, C double prime, or the reflection over line M of the reflection over line L of triangle ABC is equal to triangle A double prime, B double prime, C double prime. The figure is rotated about the point where the two lines intersect, in this case point Q. So here is point Q, lines L and M are intersecting, so if we reflect our triangle ABC over line L, we'll get triangle A prime, B prime, C prime, and if we reflect triangle A prime, B prime, C prime over line M, we get triangle A double prime, B double prime, C double prime. Example 2 says lines L and M intersect at point C to form a 70-degree angle. So here's line L, line M, they intersect right here at this point C and create a 70-degree angle. What is the reflection over line M of the reflection over line L of the figure J? What are the center of rotation and the angle of rotation for the resulting rotation? The first part of the question is just what is the reflection over line M of the reflection over line L of the figure J. This is what we did in the previous problem, so I'm going to go over this all at once. First, we're going to start with the inside transformation, which is the reflection over line L of J. So here's J, here's line L. We're going to reflect J over line L, so it's going to end up in the opposite orientation, and it will be the same distance from line L as point P. So we get point P prime, and the line segment PP prime will be perpendicular to line L, where these two segments are going to be congruent. Then we will take the reflected image at point P prime and reflect it one more time over line M and get the new image in blue at point P double prime. This time the segment P prime, P double prime will be perpendicular to line M, and these two segments will also be congruent. So this blue figure here is the reflection over line M of the reflection over line L of the figure J. The center of rotation is the point C where the two lines intersect. We know that the measure of angle 1 is equal to the measure of angle 2 and the measure of angle 3 is equal to the measure of angle 4 by the definition of reflection. So here we have angle 1 and angle 2. By the definition of reflection, we know that the angle measures are preserved, so the measure of angle 1 is going to equal the measure of angle 2. Here's angle 3 and angle 4. The same applies here, so the measure of angle 3 is going to equal the measure of angle 4. So to figure out the angle of rotation from point P all the way to point P double prime, we would have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4. So that would be this entire angle here, adding up 1, 2, 3, and 4. But we know that the measure of angle 1 equals the measure of angle 2, so we can substitute measure of angle 2 in for measure of angle 1 to get the measure of angle 2 plus the measure of angle 2. We can do the same with the measure of angles 3 and 4. So instead of having the measure of angle 3 plus the measure of angle 4, we can have the measure of angle 3 plus the measure of angle 3. This gives us 2 times the measure of angle 2 plus the measure of angle 3, but we can see here on our diagram that if we add the measure of angle 2 plus the measure of angle 3, we'll get 70. So we can substitute 70 in to get 2 times 70 is 140. Therefore, the angle of rotation is 140 degrees clockwise because we started at J and we're going to the twice reflected blue J. The work for this problem is written out on the next slide. And now I would like you to try homework number 3 on page 535. Find the image of each letter after the transformation, reflection over the line M of the reflection over the line L. What are the center and angle of rotation for the resulting rotation?